Today we're going to take a look at section 1.9, which is quadratic functions and models. And the basic form for a quadratic equation is called quadrag. Looks like this. F of x equals ax squared plus bx plus c. And it has the condition that a cannot be 0. What would happen if a were 0 here? No solution, but what would happen to the equation itself? What would it become? Linear. Because if there's no x squared term, if there's a 0 in front of the x squared, that piece goes away, and all I'm left with is the other pieces, which makes a line. So that's why it says a can't be 0. You could have b or c 0. That would be okay. So some features of a quadratic equation. It has one concavity. So there's a couple options. It's either concave up. So it looks like this. Or it's concave down. It looks like that. And these are parabolas, right? That's what a quadratic is. It's a parabola. And then, that shouldn't say concavity. That's a typo. You may see a change in behavior. That's the word I want there. So make that change for me if you've already started writing. You may see a change in behavior. So what do I mean by that? Well, you may see it change from increasing to decreasing, or from decreasing to increasing. And it says may, and it really means may. You don't have to for it to be a quadratic. So if you saw a scatter plot that looked like, that's terrible, let me try that again. This, it could still be quadratic, you're just seeing only half of the parabola, and that's okay. All right, so you don't have to see a whole parabola shape to call it quadratic. What else could it be if it had that scatter plot? It could be logarithmic, except for when we did the logarithmic, it was flipped around. So probably not logarithmic, but there was another one. Exponential, right? That would be another option too. So this has some of the same characteristics of the exponential and the logarithmic, depending on the shape of it, that we had seen in the other lessons. All right, so here's a couple of examples. This is where I told you that I was going to try and get the images in here. If you go to your book, this is what the image shows on this particular problem, which is page 92, number 9. So if you'll just sketch that real quick onto your paper, if you don't have this printed out with this on here. The question's asking us kind of what I did on the last picture that I sketched. What might be appropriate to try? What types of equations we've seen so far might be appropriate to try? And they've given you all of them written down here that we have seen, linear, exponential, logarithmic, and this new one that we've introduced, quadratic. And you're just looking at this and deciding what might actually work. So let's just go through the list and say yes or no. Could this be linear? No. Why? It's curved. There's some concavity to it, right? Okay, good. Could it be exponential? No, not with the exponentials that we've done with our modeling, because what was true about those exponentials? They were always concave up. So this is not an exponential. Could it be logarithmic? We do have some logarithmics that are flipped upside down, but there's something else that we have that this one doesn't when we have those. Do you remember? They have an asymptote on the y-axis. Does this have that asymptote on the y-axis? No, it's like it's flipped around, right? If I took this image and I flipped it around, it would look like the logarithmics that we were dealing with. But our logarithmics, if they were decreasing, were concave up. And this is decreasing and concave down, so it doesn't work. Could this be quadratic? Yes, we would be seeing only half of a parabola, but I told you in the last slide, right, that that's totally okay. So the only one here that works is a quadratic. And the reason is because it tells you which model would be appropriate. This is because it's concave down. And concave down means it can't be linear or exponential. Right? Eliminated those possibilities. And because it's concave down and decreasing, it can't be logarithmic. All right, now it didn't ask on this one to justify the y, but you should at least have gone through the y in your head in order to come up with that conclusion, right? Yes?
So we only need to write that when it says y?
Yes. If they asked why, you would write something of the justification that looked like that. This one doesn't. I'm writing in here in your notes so that you'll remember what we thought about. Yeah. All right, I have another one very similar. Could this be linear? No. Because it's concave up, right? How about exponential? Exponentials can be concave up. There's something wrong with it that's not the concavity, though. The end behavior. The end behavior with an exponential has it leveling off on one side, and this one doesn't, right? In other words, or you can talk about whether it's increasing or decreasing. An exponential is always increasing or always decreasing, and this one's both, a portion of both. Yeah, so exponential is no good. How about logarithmic? No, again, a logarithmic is either always increasing or always decreasing, and this has both. So quadratic's our only choice here. So it's not, well, let me say it, I'll do it the way I did in the last one. This one is decreasing first, then increasing. So it can't be exponential or logarithmic. And it's concave up, so it can't be linear. Okay, so there are times in your book where it tells you use this model, and there are times where it gives you something and it tells you to choose a model and you have to pick which one. So that's why we're sort of thinking through, if I've got a dot plot, a scatter plot that looks like this, what do I do? And that's what we're looking at, okay? All right, let's actually do one with a scatter plot then. So the following chart shows the profit of a company when they are selling blenders, the number of blenders sold, 14, 17, and so forth, with the price of, I think profit is the word it was supposed to say, not price. So this should say profit, that's what it says on your paper. Profit, that means how much money the company makes, is given. It says, is a quadratic model appropriate? And this one does say why, right? So we are going to have to justify the why on this one for sure. So let's take a look at the scatter plot and see what we get. No aligning here, notice that, right? No aligning. Okay. So everyone's scatter plot look like this. Any concerns with your calculator right now? I know a couple of you had concerns at some point and you kind of wait till the end of class, which is okay, but if you have an issue and your calculator's not showing what mine does, let me know. We can probably fix it right now in the middle of class, okay? So that goes for all the time. Does everybody's calculator look okay?
Mine's blank.
Yours is blank. Your plot's probably off, so hit y equals. Okay, the plot's here, hit on, that's good, so it's 9. Okay, anybody else has a calculator not showing the dots like this? Excellent. So is a quadratic model appropriate? Yes. Why? Concave down and it's increasing and decreasing. Very good. So that's our why. So quadratic model is appropriate? Yes. Because it is concave down. And increasing, then decreasing. And part B says, let's find that model. All right, so if you exit out of the screen and you go to Stat Calc, just like our other ones, it's actually number 5, quad reg. Okay, it's right there on the first screen. So if you select number 5, mine makes me hit Y1 right here. If yours takes you to another screen, hit Y1 in the store equations. And this is the values, these are the values that I'm getting for the A, the B, the C. Is anybody getting anything different than that? Okay, fantastic. So we're writing these down with how many decimal places? 3, always 3, fantastic. Okay, let's do that. So we need a name. This is profit, so I'm going to call it P of X. Give your function a name. I have negative 1.808x squared plus 100.326x minus 934.22 or 223. There we go. 223. I've got my equation on there. Now what do I write down? Dollars. And you can say dollars of profit if you want, but at least the word dollars needs to be there. Dollars, and then what? Where X is the number of blenders sold. It would be not a bad idea for us to graph our function. I didn't do that. Maybe we should have. Let's go back and check it out. Yeah, it looks pretty good. Does yours look like that? Good. All right, so our graph looks pretty good. I think we have another part to this one, don't we? A couple more, actually. The next two questions are related to the context of the problem. They're using information to actually figure out whether things make sense in context. So part C says, why could they profit less when selling 29 blenders instead of 26? How could that possibly happen? And it is in your table, I think, even straight out, right? 29 is $446, whereas 26 blenders was $451. How is that possible in a business context? Do you have an idea?
Because when you increase the amount of blenders sold, that's increasing the quantity that you're making, and you could be increasing your workers, and so then you have to pay for that. And
Okay.
So in the long term.
So you might have an increase in the cost to actually make them to do so. That's definitely one possibility. There's another possibility too. So there's at least two options here.
Maybe you don't sell some of them, so you just like have a loss.
Okay, but you're right, that's possible, but that would actually be justifying the other way around, right? You have a cost that you didn't actually sell for. Here you're actually selling more and making less.
Maybe there's some type of deal.
Yeah, that's it. There might be a deal, like what? Like a buy one, get one free, or a 50% off, or a, you know, a discounted rate, or flat out just a sale, right? The blenders today are $5 off. So you might actually be making less per blender because you're selling them at a discounted rate of some sort. So those are two very good reasons that you can have, and I think those are the two that I have listed on here. Yeah, they are. Good job, guys. Okay, so one option is that there might be an increased cost to produce them. So that could include staffing, right? Increased number of workers. Is it Lainey? Right? Like Lainey mentioned. It also could be an increase in the actual physical components of the product, right? You have to buy more of them. So an increase in the hardware, we'll say. Okay, the actual product you're making itself. Another possibility then is that you might have actually, in order to sell more blenders, you might have decreased the price. I.e., you might have had some kind of a sale going on or a deal going on. Okay, so is it possible to have a decreased profit even though you sold more things? Yeah, it's definitely possible. So the sweet spot's the top, right? The top of the curve's where we really want to be, and we're going to talk more, I think it's not until chapter 3, about how we get to that sweet spot. How do we get to that maximum point? Because maximizing our profit would be the goal if we were in business, maximizing our profit. So second one says, the second contextual question says, when will the company begin to post a negative profit? All right, so we're going to have to go back to our calculator to do that, but negative profit would mean what contextually? I mean, context of what's going on. Are we selling blenders if we're posting a negative profit? Yeah, we're still selling blenders, but what's happening?
Our expenses is more.
Yeah, our expenses are more than our revenues, right? The cost to make our items is actually more than people are paying us for them. And that happens at the beginning of a product being sold. So we expect that at the beginning. We don't want it to happen if we've sold a whole bunch of them though, right? At some point we need our profits to be positive and not to go back down into the negative. So let's take a look at what happens in terms of this in our calculator. Okay, so we have this screen we've been looking at already. Oops, as I went off. And what we want to know when it goes back down on the other side, right? So I need my window to get bigger and to go down into the negative part in order to see that happen. So I'm going to hit my window button. I'm going to make my X max window go bigger, and I don't know exactly how big, but 50 might be a reasonable guess. And I need my Y minimum to be negative as well, so maybe we'll just say, let's see, our maximum's at 500, so maybe we'll say negative 100, just for scale. And yours doesn't have to be the same as mine, but you do have to see the component where it crosses the x-axis. That's what you're looking for. So do we see this on this graph? Yeah, we do. There's two ways you can find the location where it crosses. Actually, there's three. Well, I guess maybe four. One way is you could guess, and you could just randomly plug numbers in. That's probably the least effective way. That was the fourth one I just threw in, guessing. It would be not terribly efficient, but it's possible, okay? Another option is you could trace, and that's not as bad as guessing, but still you're sort of having to do a long process to get close to the value. So that's my second one where I said, well, there's three. Okay? The two better options, the two best options. One option is you could do like we've done before, hit y equals, make this say 0, and look where they intersect. Okay, so I'll do that one with you first. Second, calc, number 5, intersect. Hit enter twice, and then they actually do cross twice, but they only cross once in this window, and it's over here. And I know you're like, cross what? Well, we put in y equals 0, so there is a line on top of the x-axis here that you can't see. It's just overlaid on top of it, so they're crossing right here. So just arrow over a little bit closer to that location than the one that's on the left, and hit enter. And this one tells us 43.64398. Okay, so this is one option for finding the x value we're looking for. Let me show you a second option, just so you know it. This one works all the time, which is great, but let me show you a second option. If you hit second calc, you could select option number 2. Option number 2 is a 0. It's when the function equals 0. Now the notations at the bottom are a little bit different. Instead of saying curve 1, curve 2, or whatever it said on the other one, it says left bound. You see my blinking dot at the top? My blinking dot needs to be on the left-hand side of the intersection where it hits the x-axis. And it is. So we're good to go. We can hit enter. And then it's going to say right bound, which means I need to arrow over until I am on the right-hand side of that location. I think I'm there. Do you see my blinking dot? It's on the right-hand side, right? It's below it and on the right. So we're going to hit enter. And then guess just means you need to be close to the value in between there to hit enter, and we get the same thing, of course, 43.64398. Okay, so I want to write that down first, x equals. So back on our paper, we're going to write p of x equals 0. That's what we're finding. And we found out x equals 43.644. Right? I mean, that's the calculated value. But what is it calculating? What is x? Blenders. So if I write down 43.644 blenders, there's something wrong with that. You can't sell 0.64 of a blender, right? That doesn't work. So we need to figure out, do we round up or do we round down? And there's really a reason we're going to round up, and it's not because it's 0.6. It's because if we sell 43, I'm still making a profit. And you can check it in your calculator. If you go into the table and you put in 43, it's going to show you a positive number, but if you put in 44, it's going to show you a negative number. So in terms of the context here, the correct answer, not because we round with regular rounding rules, but because of the context, is that the answer is 44 blenders. And all of what I wrote down is what I would expect to see on the problem. This piece shows me that you did it using an accurate method, right? You're finding a level of accuracy that's appropriate. And then the 44 blenders shows me that you understand the context of the problem, that you can't have any decimal places, and you're rounding appropriately. Yes?
Would it be okay to write when the amount of blenders sold is greater than 43?
Yeah, you could say greater than 43. That'd be okay. Sure. Now, and it says begin. So that's going to be our key too. So like if you found out, if you were guessing and you said 45 works, well, it does work. But we want to know the first place where it works. So like when you're saying greater than 43, that would indicate it. Saying 44 is the first location would indicate that. Any questions on this? All right.